Good morning, good afternoon, everybody. Thanks so much for joining this next episode of In a Nick of Time. And we're going to get started about 5 minutes with Pritesh joining us. He's the CEO of Ad Hoc Research to talk and really understand what digital engineering really means. So stay tuned for another 5 minutes. We'll get started. Good morning, good afternoon, everybody. Thanks so much for joining this next episode of In a Nick of Time. We're so excited today to be able to do a deep dive on digital engineering. It's a pretty hot topic in the Department of Defense. It's been really a topic that many talk about, but not many understand. So I think it's important to bring an expert with decades of experience doing this in real life with very complex weapon systems and the actual DoD mission systems, so you can understand really what are the key pieces of the puzzle to get this done. So we're excited today to have Pritesh Patel, the CEO of Ad Hoc Research, to join us. So before we get started, I wanted to remind everybody to subscribe to In the Nick of Time by going to inthenickoftime.tv. We send an email a week for the next episode, so you know what's coming up. A lot of great guests coming. It's going to be a very interesting month, both in March and April. If you know someone that you think would be a good guest for the show, trying to get more people also on the .gov side outside of DoD and the IC. So if you know anyone that's would be interesting to join the show, please reach out to us so we can reach out to them to have them on the show. We're pretty much booked until beginning of June, but that's going to be pretty tight anyway. So just send us whoever you think would be a good fit. I wanted to remind everybody, if you've not tried it yet, to go check out Sage.ai. It's the GPT for government. We're bringing different models, OpenAI and Cohere and Google soon, to be able to add the CUI data on top of it and be able to tap into real-time API databases and such. So check it out. It's a game changer for many teams. We have 1,200 government teams on Sage in 6 weeks, which is insane. Pretty excited about this. So, go check it out. You can open a free account on Sage.ai and give us your feedback. We have a Discord chat, so go on Discord and give us some feedback as well. That's always exciting to hear from you guys. So, I think it's pretty exciting. So you wanna play with this? So let us know what you think. You can have CUI on there and all that good stuff. So pretty exciting. With that, we're gonna bring our dear guest. Before that, I'm gonna give you a quick rundown of who he is. Pritesh founded Ad Hoc Research in 2013, supporting the Army Evaluation Center C4 ISR Evaluation Directorate. He led the modeling and simulation tool for analysis, fancy acronym MODESTA. It's a test framework for automating the Army mission system testing on a synthetic technical network test bed, which it will be interesting to understand what that means. I think a lot of people struggle with all these fancy terms, but I think we're going to do a deep dive today to really kind of democratize all of this stuff. So that's going to be interesting. Also, the obviously has 15 plus years of deep knowledge and modeling and simulation, test evaluation, DevSecOps, and you're gonna see that some of the stuff he brings is kind of embedding all this cool modeling and simulation stack into Kubernetes and how to do this and how to embrace cloud native inside of this new construct, which is so interesting. And of course, he has a deep background on infrastructure automation to be able to get where you want to be at the velocity and the pace that you need to move at to compete. His strategy led to the companies to rank in the 28th fastest growing business on Inc. 5000 in 2020, which is pretty amazing for a government team. Pretty unheard of. Um, and with that, you can find him on LinkedIn. The link is right here. Always follow him. Always a lot of great insight. And with that, we're gonna bring him on. Welcome.
Hey, Nick.
Very good to see you. We're so excited to have you. I think it's going to be a very interesting discussion today. There's a lot of great questions already from the public. A lot of people, use terms that we don't always understand. Digital engineering, modeling and simulations. SysML. Obviously, digital twin. Now the fancy modern way, right?
Mm-hmm.
So it's going to be an interesting discussion. Before we get started, I think it's always good for you to share a little bit about your journey, and then we'll be able to start a deep dive on digital engineering.
Yeah, absolutely. All right. So my journey has been very interesting. I served in the army as a soldier, a counter soldier. And I first started with the two biggest acquisition failure programs. That's become a textbook case like FCS and Deep Water program. So when the large acquisition programs were forming, I was put on a very interesting projects to do a lot of risk reduction and experimentation. So sort of I started my career with the acquisition of failures and how to use, but still learned a lot of how to use modeling simulation and experimentation to reduce risk on the larger programs. Unfortunately, those programs did not survive, but Deepwater still went on the Coast Guard side. But that's how I really started my career, and then worked on Army's WINT program of record office for 5 years, and then I took a chance and started my own business after that. So that's really my journey, and I definitely have a really great team now to support, and we're doing some great things going forward here. So
Yeah, no, that's
yeah,
exciting to do a deep dive on this because
yeah,
so
hmm
many different companies doing different things. A lot of
hmm
pretty legacy ways of thinking of this, right? A lot of tools that
yeah,
are 20 years old, right? And so bringing kind of the modern automation model, the DevSecOps mindset, all these kind of new ways of doing business
hmm
and moving at a pace of relevance is kind of the disruption there. And there's a lot of momentum when it comes to digital twin. Air Force started really pushing this with Dr. Roper, with the the three pillars with DevSecOps, open architecture, and digital twin, and that
hmm
really kind of started to really show the teams the value of automation and knowing how a system is going to behave before bending metal. That I think was a pretty game changing piece. But if you have to summarize what digital engineering is about and why people think this is important, how would you describe it?
yeah. So digital engineering is from the traditional methods of on the acquisition program. You know, uh, Leveraging modeling, simulation, and test and evaluation has always been the mandate, right? Now, with the new digital engineering mandates, this is more formalizing and some of the processes and tools that you and consolidating in the cloud is what the efforts been going on, right? Now, traditionally, models actually for what you actually intend to build has been more on the sort of like building some kind of like models, which is much more lengthy. Traditionally, it took like 6, 8 months to even build the first models. But how do we accelerate that process, right? Like, how do we leverage actually existing data and actually use AI ML tools to build model, accurate representation of the new system or new things that you're trying to build is a really the more path forward looking for these DoD programs, right? So times have changed, right? Like now you have more cloud native capability where it can be much more agile and not be take a lengthy time to build models and still be in the iterative cycles of doing simulations and sort of deciding and actually doing more stochastic models, but trying to add more realism is definitely a game changer going forward. The most important uh, uh, point in digital engineering is digital threads, right? In military weapon systems and DoD systems, you're just not trying to build a representation of one component. You actually want that to work with all of the other aspect of it. Like, so let's say you want to add a new technology that is for the edge device or something doing that the soldiers carry with them. But how does that, what value it provides to all the way up to the core level or any other commanders or the decision making process, that has to be evaluated thoroughly. So the digital threat aspect of bringing creating a representation of complex and the threads that goes with it is very, very important, right? So you not only heads not focused to building only one thing, but also bring in the entire aspect of it. So uh, that's one of the good things in the recent mandates I've seen in digital engineering to push that aspect of it too. So that's certainly uh, there's a lot of value for the DoD programs to practice, right? So
Yeah, no doubt. I think, when you think of the complexity of some of these systems, right? Back to your
mhm,
point, having the ability to really see how they integrate with the rest of the ecosystem, and also,
mhm,
keeping track of what's going on with physical events, right? Whether it's weather related things, whether it's the situation that the warfighters are set in, all these different customizations will give you a lot of insight when you're building a pretty complex system like this. And I guess it's kind of a maturity, thing where, the more you're able to really mimic the real world and everything around you and how things connect.
mhm.
The system of system thing becomes kind of this almost virtual world, kind of a metaverse of what's going on, right? And so that will give you a ton of insight, both in terms of how the metal is going to behave, all the way to how it's going to be used, and the kind of the conditions and what you need to pay attention to when it comes to designing the product.
Yes.
Too many times we spend 5 years, right, trying to figure things out, and then all to realize that it's just a complete waste of taxpayer money because we built it in a vacuum. So that kind of digital engineering model
Mhm,
will effectively accelerate the rapid feedback, with the fighter, and be able to avoid wasting a bunch of money. But I guess it's interesting, right? Because when you look at the challenges, right, and that's kind of my next question, you know,
mhm,
when you listen to the definition, it's like, okay, that seems to be a pretty high bar, right, to get where you want to
mhm.
be, and you don't get there overnight. And if we listen to the normal DoD way of doing business, that means people are going to spend 5 years to design a model, all to end up building something 5 years too late. So how do you find the balance, right, between maturity in digital engineering, but yet DevSecOps, and kind of deploying stuff in production and getting feedback, and kind of balancing kind of the virtual world and the real tangible outcomes?
Yeah. Yeah. So some of the top challenges are in digital engineering adaptation. I feel is are in the standardization aspect of it, right? Um, it is it, us being we have been plugged into the army modeling simulation community for quite many years, and we're still see the common framework of scenarios of issues, the common framework of models. Um, Certain systems are represented in three different simulation environments and not consolidating into one. And the and whenever you have stochastic models, it is there's always skepticism that well, the simulation produced that result, but I there were a lot of assumptions to it into it. So the chat with digital engineering aspect is there's always sort of this continuous skepticism in the mind that this at the end of the day you guys have just flipped the coins and how should I believe these results have to make my important program decisions. There's always been a challenge, right? um, and again, emphasizing on like standardizing and bringing the community together is very important, and all working on a common framework of scenarios, common sets of data, common processes is actually very challenging, right? The other aspect is also you know finding the data set, and if you're trying to build a model from actually existing data, that's at this point in some of the areas it's still challenging to bring that into a cloud so other community can utilize that data to build models. That's still still not, we haven't seen that happening yet, right? So,
Yeah, so
but
you're still facing the same data issue, I guess, that you see right
yeah.
across pretty much any use case, like bringing the data in, and then of course, I guess you were talking about all these siloed modeling environments. I guess there's the
Mhm.
point of having maybe somewhat of a centralized mindset when it comes to designing things. So at least in terms of the design of the models and the format, so they can be reused across teams and because
Yeah.
yeah, you're as good as your representation of the other models you're going to integrate into, right? And so you have this dependency across teams, right?
Yes. Yeah. Yeah. And we talk about um, always CI/CD, right? Like we talk about CI/CD and DevSecOps a lot. But on these programs, where we don't talk about is like CVNV for system to system, right? And that's
Right.
where digital engineering tools adds a lot of value to that as well, like practicing VNV and actually calibrating the models along the way is actually uh, you know you know
Yeah, so Michael had a couple of questions for you, and I think I'm gonna take them now because they really go well with the topic here.
Mhm.
And so Michael was saying, as you explaining this digital thread and models, can you give a couple of tangible examples of digital twin, with a DoD example?
Yes, absolutely. So um, So think of like from the mission systems that you have that soldiers use, like for situational and C2 information, and then they for fires mission, right? So there's complex thread that goes in of taking the orders, and there are so many buttons being pushed and so complex things that happen behind the scene, right? And many times when you do these things in a lab, you do it on a network, like all wired network. But the realistic representation of network of the networks, because in DoD we in a tactical system we use even hierarchical or some heterogeneous networks. We forget about the representation of that, right? Now, to execute the thread, you thought it worked in a lab perfectly, but now you were missing some pieces,
Real
right?
life is not a lab, right? Yeah, no doubt.
Yeah, yeah. So that's a great way. So, some of the things we've done in the Army and C5SR, how do you virtualize the radios and put that into a container environment to bring that hyper realistic networks too, right? That's a digital twin of that
Right.
network
And you
representation.
want to bring that latency and like stuff going down and right, so nothing is working perfect. Maybe you're swapping between different kind of connectivity options. So some people manage to get access to faster
Mhm.
5G, and then you go back to like legacy connectivity. So obviously having those abilities, right, gives you pretty good insight when it comes to handling errors and network issues and stuff like that.
Yes. Yeah. So
Yeah.
that's one of the core example of digital twinning and execution of threads on the all of the digital twins that you created, right? So.
Yeah, and Michael had a follow up, kind of for me as well. But
Mhm.
he was asking if we were, Ski Camp did a great job when I was in the department to build the digital twin of an air gap network and F-16 payload using AKS, and that's
Mhm.
been pretty amazing to see what they've been able to do, with the legacy platform there. And F-16 has been kind of leading the way, honestly, when it comes to adopting all these modern practices. And he's asking if we've seen other, digital twin growth in Platform One or Run or AFRL and others. For me, I've seen quite a few big programs. GBSD is probably the biggest example of that with B-21. Well, they've done a very good job at really modeling the system, and it's pretty complex system, particularly for GBSD and B-21, really, where you have all these different dependencies and the silos, the missile, the payload, all that stuff. So it's pretty amazing to see what they were able to do. But it seems to be very much using legacy tech stacks and kind of completely siloed compared to the DevSecOps side of the house, and it's often running on Windows machines, on the cloud or on premise, and it's it's kind of interesting how there's not a lot of companies, right, innovating in this modeling world. So what have you seen so far when you come? I think Dr. Roper just announced like 2 months ago that he's building this new company to bring digital twins to the department at scale. What have you seen? Who is doing innovative stuff?
Yeah, so we have seen quite a bit trend. Like, and I think everybody's most of the common things that I've seen in the industry is that everybody's realized that uh, when it comes to digital twin, um, you know, digital twin platform needs to be. It cannot be. It's not a turnkey solution. I mean, everybody wants models that is complex. So the trend I've seen is that I'm seeing multiple platforms that are taking the low no code approaches to build models, right? So you don't have 6 8 month cycles to build models, right? So how do you, like, for example, in some of the benchmarking we've done through low no code approaches, we built a SCADA ICS system digital twin model in just 2 weeks and a single data scientist working on it, right? That was a benchmark. How quickly can we move, right? And that's also validated, right? Like it's not just we build a model and it's done. Within that 2 weeks, we also went through a V&V effort as well, right? So I'm seeing trends of when it comes to digital twin, a low no code platform. Think of here as a SharePoint of business process applications that you can quickly deploy. Digital twin platforms also need to look like that. Well, while some platforms and some capabilities that I've seen out there, they like IoT devices and things like that, they build specific virtualization or behavior that does very specific things. But when it comes to military systems, is is changing all the time, right? So you want to have a platform that is very very flexible, and that's a trend I'm seeing in the industry right now.
And I think there's a pretty significant vendor lock-in with many options, so people have to pay attention to that, right? And
Yes.
using open formats and being able to reuse models, particularly when you have different teams buying different tools. If you can integrate those models between teams, obviously you lose the entire value of that digital thread, right? So that
Yes.
is the foundation of the right decision. And when I right before leaving, we were working with the Air Force to create this, and I'm blanking on the name of what we called it, but there was this new modeling and simulation environment, enterprise wide on Cloud One, that would be bringing kind of all the key enablers, right, for digital teams, just like a platform one, but for digital twin, to be able to do that, so teams don't have to set up all the tools and kind of accelerating their adoption and how to get started. I think that was a pretty good idea, right? Would you recommend maybe teams to have an enterprise service for all these tools, so not every single team has to reinvent the wheel?
Okay. Are you referring to DAF DTO office or
Yeah,
the? Okay.
right.
All right.
That's it.
Yes.
Yeah,
Yes. Yes.
there we go. That's the
Yeah.
name. And they've done a great job,
Digital,
right?
yeah, the digital
Yeah,
transformation office by.
digital transformation office. Yeah.
Yes, yes. I seen that initiative. Very interesting, and I think that's one of the great initiative I see. And the earlier pain point I talked about, the standardization and common is I think that such platform can enable that. So which is great. So
And Michael is always spot on here, but he's always spot on anyways. But he's mentioning, I guess, that they're setting up the stuff, but first, we're not very good always, at
mhm.
Hanscom and others to build enterprise services at the right cost, and then programs always say, well, I'm going to do it myself. It's going to be cheaper, and then they realize, well, maybe it's not that easy and that cheap, and then they end up spending more taxpayer money. But there's also the issue of like organic resources and talent, and centralizing, one would argue centralizing the talent into one office would make sense to help bring an enterprise service, but it's not always easy to find the talent. And when there's no big push from the top. After I left, I think kind of the momentum of like the centralization stuff died
Hmm.
away. Then you have a tough time to find the talent, and then it's kind of a compounding toxic effect, right? Where you don't find the talent, you're too expensive, people don't want
Hmm.
to use the enterprise service, and so if they don't use the enterprise service, you don't have enough money to make it cheaper. So it's kind of a vicious cycle.
Yeah.
Um, yeah. So when we look at the difference, I guess, with what people use now as a term, which is digital twin, and the
Hmm.
traditional modeling and simulation universe that's been going on for years. What would
Hmm.
you say is really kind of the difference, or the modern way? Is it just a cool name that just sounds better and does the same thing, or is there, like, would you say there's some requirements or outcomes that would be very precise with a digital twin, just like DevOps and DevSecOps is not, it's it came from the same place, but these additional requirements to call yourself DevSecOps versus DevOps. So would you say there's a similar mindset when it comes to digital twin?
Yeah, so yeah, the key difference, yeah, digital twin does have the same mindset like cloud native, Kubernetes deployment of or like some orchestration and provisioning engine where you can deploy digital twins. That's the deployment and execution of simulations or something that what you want to do with the digital twin. But the core difference between digital twin and modeling simulation is the real time model updates and aspect of it. So imagine you have a some sensor or some system on the edge side where you push a new software update, and now all of a sudden there's a new behavior that is actually introduced in that. In the traditional modeling simulation, you would have to go and code the new behavior along with the new system that you actually have built, and there's no real-time update to the model, right? So traditional model, so everybody has different opinions about digital twin versus modeling. So my opinion, and just my 2 cents is that there's a real-time model updates and real-time representation is what really differs between the two, right? With the new way of building models uh, from data, which is a new methodology, right? Than the traditional models, right? And the way we build models is also more agile in digital twins. It shouldn't take you to 6 to 8 months to build models, right? So that's a core difference that I see, the real time aspect of it. So if you have, yeah, and so if you have, like, let's say a uh, you know edge device, kind of, you want to do a core analysis right on the edge device where the digital twin is also co-located, and do your water drills right then and there on a centralized exercise. There's a lot of value to that, right? So
Yeah, so you bring it with you, right? So it's not just in the lab.
yes, yes,
Yeah. So it's more than a fancy terms, I guess, right?
yes,
So that's
it's
good.
yes, yes, it's not.
I think it would be interesting to have a really good understanding of kind of
Yeah.
the definition and the key. What we did pretty well. When I did the DevSecOps
Mhm.
reference design in DoD, we kind of really established what were the key mandated pieces to call yourself DevSecOps versus DevOps. I think it will be interesting to have a
Mhm.
similar exercise when it comes to digital twin, so people can actually really understand the definition of it, right? And the
Yes.
key aspect. Are they checking the box or not? I think that's interesting.
Mhm.
Um, so obviously, when you look at creating these models for complicated weapon systems, that seems like for many teams, impossible, particularly when you start from scratch. And you
Mhm.
shouldn't start from scratch, right? Reinvent, how the wind is going to behave and whatever else, right?
Mhm.
Radiation or whatnot. I mean, who cares? Whatever the use case is.
Mhm.
But still, it's a pretty heavy lift. What do
Yeah.
you see? The top three mistakes people make when they get started on the new digital twin engagement.
Yeah. So Yes, this is a great question, right? Whenever it comes to creating models, like in whenever you have to keep one thing in mind, that the purpose of creating models is to answer questions, questions that decision maker seeks to make important funding decisions and program decisions, or whether it's testing or anything like that. So when you're designing weapon system models or any other representation, time is of the essence. You can't get into the long cycle of model developments to to make it so precise, and kind of build the stochastic models, and hard, like intense coding by reading from the specs. Like I've seen methodologies that people read the specs of the system and then start coding, and some descriptive and simulation engines and things like that. uh, we don't have time for that. Decision maker seeks an answer. Their answer. They were seeking answers. They wanted answers, yesterday. But um, so that's an important fact. And so trying to adapt like low no code approaches to building models. There are three main categories of model development that I recommend: is spec based, which is taking the state machine based model development, right? Quickly, that you can build that through very easy. Like for example, let's just take a traffic light or elevator. There's a state machine for it, and adaptive low code platform to build that model and quickly move, and instead of doing a lot of intense coding. The second way, a way of the if the system exists, right? There's a prototype that exists of the system. Then create an emulation-based model, by virtualizing the key core components into containers and microservices, and draw boundaries around, and bring in partial behaviors, again through workflows or some kind of state machine behavior models into that emulation base, right? And the third methodology, if you have data, leverage AI ML tools and machine learning processes, MLOps processes, to build representation of that component using machine learning models, right? So these are the three categories you can build models. But models built out of real world data is always very close to the realism. Models built out of emulation, virtualizations, all is also close to the realism. So that the results coming out of those emulations or simulation exercises are sort of like more realistic, and people will believe it more. There's no lot of coin flipping going on, and where you need to run simulations 30 times to gain confidence in your results, or none of that stuff, right? So these are the kind of common things that they need to keep in mind. If you can't, try to get the model move faster, and try create a strategy to create models more realistic through some of the strategies that I just described.
Yeah, that's interesting, right? Because I think there's also a barrier to entry why people get scared of
Mhm.
like getting started, right? And it's like, okay, if I start bringing a model that's not good enough, it's gonna start
Mhm.
giving me the wrong insights, and so it's gonna be counterproductive. And then if
Mhm.
I aim for perfection, it's gonna take me a year, so that's useless, right?
Yes.
So how do you find people mitigate kind of that good enough decision to say, okay, what's the lighting bulb moment where you say, you know
Mhm.
what, this is good enough to use it?
Yes. Yeah, great question. All right. So my years of experience and working a lot of, some of the modeling simulation efforts for very large programs. If it, simulations and emulations are always, like I mentioned, they, when you brief these results at the Pentagon and at high level, hey, we believe the system is going to work, and your money's going to be worth here, but everybody, hey, these are stochastics. At the end of the day, these are models, right? Okay, that's okay. This is a model. Let's say this model produced plus or minus 30. That's okay. But it's interesting to see a core analysis that compares with the same error rate, and do the comparison across different course of actions, and still, okay, don't go by this numbers exactly, but look at the difference between the two cores. See how much of the value that it really provides, right? that's still, decision maker needs to look at the results out of the model from that perspective of comparison against some kind of baseline performance, right? So.
Right. And that's interesting, right? Because people, I
Mhm,
tell people like, I'm always worried about the DoD getting hacked, but I'm actually also more worried about the
mhm,
DoD becoming so irrelevant that no one is trying to hack us anymore, right? So
yeah.
there's always like this kind of, and it's the same thing we get with Sage. People want the model of OpenAI on the high side. I'm like, sure, we all want that, but it's $100 million to host it. So are you going to foot the bill?
Mhm,
And I can tell you, doing without it will be much worse. And probably, when you see Baidu give, their GPT stuff to the CCP,
mhm.
obviously that's a big problem. And we can pretend
Yeah.
it's not a problem, but then we're gonna wake up and realize, we wasted 10 years when they, in one year they took 10 years on us, and
Mhm,
that's not acceptable. And so sometimes, right, perfection is the enemy here. And so,
mhm,
so looking at progress, right, progress can be measured. Might not be where you want to be, but it's still better than not having it. And so I'm always, I always push back a little bit, right?
mhm.
Particularly with this kind of AI ML innovations, because it's so expensive and so difficult, right, to get it done. You can just pretend you can do without it and think it's
Mhm,
not going to have an impact. So there's a cyber aspect of things, and then
mhm.
there's a velocity slash innovation piece of stuff where if you don't have that, it's pretty worse than being fully secure. You can turn off your laptop and be secure, right? I'm not sure you're going to be able to succeed, right? So
Yes, yes.
yeah,
And pretty soon, it's going to be a war of AIs, like, beating each other's algorithm. And, simulations and emulations are at the center of it. How do you beat
yeah,
them at their game, right?
right,
Without creating the replica of the wargaming and trying to figure out what is that black box kind of things they're doing, and us to even figure that out is there's so much of that value
right.
in digital twinning and doing continuous iterative exercises, right? So
Yeah, no doubt. When obviously I'm all about ethics, but at the same time, I know that China couldn't care less about ethics, and I
yeah.
can tell you that they're certainly going to use GPT, their GPT, to do some cyber offense, writing malware and whatever else. I have zero doubt it's already happening, right? And yet, in the U.S., we're preventing U.S. teams to do that on the offensive side, on Cyber Command and NSA, but you know at least if you read the terms and conditions of OpenAI and others, you can't do that.
Mhm.
It's interesting, right? I get the need of like, you know, thinking of ethics, but at the same time, I also know that AI is kind of the next generation nuclear weapon, right? And so if you don't
Mhm.
have it, you're in trouble. And so we don't want to use it, but we need to have it, So it's just interesting, right? It,
Yeah,
it,
it
it
is.
creates a whole set of challenges again. But
Yep.
let's go back to the benefits, right? Because people that
Mhm.
push back on digital twins, they say, oh, you're spending a lot of time, and if the model is not good, you're not going to see a lot of value back. Sure, like anything else.
Mhm.
But what would you say are the big, return on investment benefits, for teams adopting, embracing digital twins?
Oh, yeah. Digital twins provide so much value for large scale programs and even system and system representation, not only the DoD program, but even commercial or even civilian. Like, for example, the recent event that we saw on FAA that, bought that database operation, kind of brought down
Yeah, the
the
NOTAMs.
price to the ground. I mean, imagine they were doing continuous exercises to do some kind of chaos engineering. That could have been avoided, right? And also chaos engineering that leads to a high availability and resiliency plan. If that happens with a click of a button, I want actually that to spin up for the last good snapshot of the application system as well, right? So that's there's so much value, right? From DoD program perspective, the benefit of digital twin is like from start to the end to the sustainment, right? The model evolves as the program evolves, right? The models and simulation environments or emulation environment can support the training as well once the system is fielded, right? At each and every milestone and touch points having a digital twin and models is just gives a lot of value for all the decision maker throughout all the critical points. Going to forming the first prototype system and see how it behaves with other systems, um, and at the same time, sort of, making informed testing decisions and all that, right? And the most important factor now these days are for all of the systems that we actually, if we have digital twin and having a live mission that is happening and a replica up in the motor pool or some kind of in the cloud where we know what threats we are facing. So preparing the troops for variety of non-kinetic and kinetic effects they are about to face, because the war and the enemies all they always have new strategy to. So whatever intel that we have and what their game plan might be, to rehearse on in real time is there's a lot of value into that, right?
Yeah, no
uh,
doubt.
yeah, so that's that. And there's, like I said, a lot of commercial application as well, right, for that. So
Yeah. Someone was asking, how would you bring the value to smaller programs, right? Small to medium space companies.
mhm,
We see the same issue with software, right? I have a couple of friends that left SpaceX, right? They were leading the DevSecOps teams at
mhm,
SpaceX, and then I realized, wait, I had 100, 200 people to do this at SpaceX, and now I'm in a startup, and I have 9 people for software. I need 20 times that just for DevSecOps. So how do you reconcile, DevSecOps and all the digital twin infrastructure and all the stuff you need
yeah,
to do it when you're a smaller company?
yeah, yeah. So for smaller programs, in some smaller systems that is being developed, there is always the risk associated whether we integrate or do. Are they going to be able to show a better value to the big program, or there's always that. But not necessarily the small companies don't have access to these kind of full system of system representation that can execute the full digital thread and show the value, right? So there's always a challenge with that. Like when we, as a small business, we struggle that too. We build notional stuff to do demos, right? But then I want, but this has so much value to it that let's look at the big picture, big war game, right? Like so if there is a representation of the full system of system, without buying a lot of uh, licensing or others labs that you need to connect to, this eliminates the need for that, right? Like kind of get some area of representation in a synthetic environment for a smaller system and smaller programs to connect with hey, this is what we would happen for the whole system of system representation. uh,
I'm talking to myself. I'm
okay.
muted. So I guess he had a good point here. He was talking about,
Mhm.
y- you know, could the government bring a turnkey solution to those programs and those smaller companies, and just
Mhm.
like a platform one of zero twin? And that was my idea, kind of removing the barrier to entry by providing kind of a turnkey cloud-based stack, right? That contractors and government teams can use. Do you see this as an accelerator to have maybe some enterprise capabilities for
Mhm.
organizations to just use?
Yes, we see my vision and no one, working in the modeling simulation community for so many years, a community and a system that is so open that everybody can get on and it's easy to use. For example, let's say you want to deploy a model on Kubernetes cluster, but on your team you actually don't have a Kubernetes engineer, right? But is there a capability out there that would eliminate the need for specialized skills that you have, right?
Right.
How do we bring that open community that where people can come and build their stuff and they still own it, importable, exportable formats, and they can use it and share stuff. A platform, a cloud native friendly on-prem or in cloud, a platform is the vision to go, for that, right? So,
Yeah. Yeah, no doubt. I think we had a few engagements with OSD R&E, when I was in the government to help them kind of get access to Platform One and kind of streamline access to, the DevSecOps stack. So teams that don't have the knowledge, right, they can
mhm,
just go on Party Bus and use stuff without having all the skills, the internal skills to run the whole pipeline. And so I think, same concept with digital twin stuff, I guess.
yes, yes,
Um,
it is.
So Robert was saying, we talked about cloud. Do you see, cloud-based digital twin as a wave to the future? And obviously they can scale faster. And would you see cloud hosting? Obviously there's always risk anywhere you host it. I would argue it's probably, less secure in the DoD network because of our lack of hygiene
Yeah.
and basic cyber hygiene than most cloud providers that we trust. So what do you see there as a next, adoption?
Absolutely. I think many organizations are already started the modernization effort. Everything surrounding around Kubernetes. Recently, I participated in one of the industry day for a modernization or effort on the modeling simulation program, and in the center they had put in Kubernetes. I would say it's not cloud-based digital twin, but more like cloud-native technology for digital twin, right?
Right.
So.
That makes
Um,
sense.
yeah, because things do exist in on-prem too. There's a
Well, you
desire.
need both. You need hybrid. You need hybrid. Yeah.
Yeah, I've
But
seen a lot of
you want
customers.
the stuff to run on Kubernetes, so it's agnostic, just like we did Platform One and
Yes,
everything we
exactly.
did. Right. Yeah. For
You want to be able
orchestration.
to lift and shift between the two, cloud or
Right.
on-prem. Yes. So,
Yeah. Not everything will be able to run on the cloud, and you're gonna need to be
yeah.
able to, deploy stuff on physical systems and have a, almost like a DevSecOps pipeline
Mhm.
alongside a prototype of a weapon or whatnot, and be able to run the software automatically on that weapon and kind of do it agnostically of where
Mhm.
it's hosted. And so that's how we design, the all the automation we built on Platform One.
Yes.
Um,
Yes.
so obviously when you look at the solution, right? I guess we just talked about it a little bit, but um, the cloud native orchestration stack like Kubernetes, right, is obviously bringing that agnostic, value there, right?
Mhm.
And do you think, MBSC, you know, how do you integrate that into that MBSC world? And do you find those engineers then need to know how to code, or how do we make it easy, right, for these teams to adopt it?
Yeah. This is
There's a shift, right, in testing, for example, right? The why I'm
mhm.
asking the questions is there's a shift in testing, right, where testers now need to understand code to write the test more and more, so we can
Mhm.
automate unit testing, integration testing, end-to-end testing. And so there's a shift also in cyber, right, where people need to start making changes in code instead of command lines, right? And so more and more people have to learn how to code. Do you
Yes.
see that happening also with MBSC, where those guys will have to, whether they like it or not, there's going to be code to know?
Yeah. Yeah. I see. The that's been our focus point on our solution, right? Uh, that what we invested in R&D is like to kind of keep that in mind that, and we know it's not even on the government side. We support private sector, big telecom companies too, and there's a lack of specialized skills and workforce that you need, right? So yes, we want to go on Kubernetes. Shows a lot of value, but if everybody's looking for Kubernetes and there's not enough Kubernetes engineer, that's not going to work out, right? So sometimes, technology or platforms need to be designed such a way that not putting a lot of burden on either on the current or legacy workforce that you may have in hand. Because so for example, um, you mentioned about MBSC and MBSC tool. Like imagine you have a Cameo, like some blueprint or some kind of architecture data on a spreadsheet, right? And you want that architecture to with a wouldn't be nice if I can press a couple of clicks a button of importing that data, and I can deploy that on Kubernetes, right? Without having a specialized Kubernetes engineer to kind of build the manifest file and build all that code. Uh, Making the architecture go live, with a click of a button, is there are platforms that and solutions are out there, and we're one of them that we recently achieved that capability as well in that area. The that's a really kind of keeping the workforce in mind that you don't need specialized skills, right? So.
Yeah, so you're kind of creating an abstraction layer, and you're
Mhm.
streamlining the adoption of Kubernetes by and I think your product is Doc Stacks, right? We
Dark
got
stack.
the link at the bottom here for
Mhm.
people that want to check it out. But effectively, the vision is to accelerate the adoption by providing all the turnkey
Mhm.
automation and instantiation capabilities, right? So people don't have to understand all the infrastructure and the Kubernetes stuff to be able to run the stuff and accelerate the adoption.
Yes.
Yeah. Um, So, another big issue we see, right, is people always talking about, okay, but I have drifts, right, between what's happening in production and my design.
Mhm.
And, there's obviously real life integration things where other teams are changing their models or they're changing their system and they don't have a good representation of the change in the
Mhm.
digital twin model. So how do you see teams you know, avoiding these drifts, and how do you keep parity, right, between the real system and the digital twin?
Yeah. So yeah. So this needs to be a continuous process, right? So as a production design and system, there are continuous changes that's happening, and the digital twin that is modeled, with whatever any of the three categories I mentioned about whether spec based, emulation based, or models built out of the data. There has to be an agile process that goes with it. Any changes that occur that triggers a update to the models, right? Otherwise, it will drift, right? If someone made the change into the production designer system, you should automatically have the think of this from like a process like I know this has been very cliche, adding everything to ops, but truly a model ops process, right? A change in the production system that triggers model updates too, right? Or with the method that you develop, that may actually be simple enough to bring those changes through the code updates as well. Or if it's data driven, run the MLOps process and build the model again. Or if there was a change in spec, go into that representation system on a canvas and just update that piece of component that you did, right? So that creating a reconciliation and a model ops process would avoid those kind of drifts between your production design and the digital twin representation. Right.
Right, right. That's the way to go. That makes sense. Um, so we see DoD getting locked in, right, to some of these solutions, particularly the legacy ones.
Mhm.
When if you were in the government, what would you think about when you're picking and selecting partners to make sure we're not facing another Palantir of modeling and simulation? How do
Mhm.
we limit, I guess, the vendor lock-in while keeping the value of the product and
Mhm.
limiting the downside of it?
Yeah. So the to avoid the vendor lock-ins in modeling technologies, practicing MOSA is very, implementing and surrounding everything on modular open source. open architecture, system architecture initiative is the key, right? How the model was built, uh, the code that goes with it, if it's a AI/ML model or a spec-based model, all of that needs to be open in an open format and exchangeable, right? Cloud native friendly, where you can bring those representation of model in containers as well with boundaries of microservices approaches is the way to go, and to avoid the vendor lock-in issues, right? Moving away from legacy simulation architectures and simulations to more cloud native would be a game changer, right? And so you bring the community around. There's more openness into it, and communities working together and enhancing the capability together, right?
Right, right. It's,
Yeah.
we with DevSecOps, we built the largest DoD community of practice, and that was a massive success. Having all the collaboration we built together was a game changer, and it's ticking enough that even to this date, right, is still the biggest engagement in DoD. So that's pretty cool to see.
Yes.
So I hope we can do the same thing with the MBSC, obviously. Um,
Yes.
so when you think and you take a step back and you think, okay, all this is great. Most of the discussion we had today, what was kind of the same 10 years ago. Technology changed, right? It's getting
Mhm.
better, it's getting easier, right? But what's big, right? What's gonna really disrupt? Is AI kind of that big disruptor? What else is there, right? That's gonna, when you think of innovation and where you think the market is going, what else you're paying attention to, I guess.
Yeah, one of the closest thing I'm paying attention to is as AI/ML is being adopted, almost on all programs, everybody's using and adopting AI/ML capabilities. The next big thing and the biggest question is how do you automate uh, experimentation, testing? Uh, hey, I have AI, machine learning model using X algorithm versus Y algorithm, and which one is better, optimizing and testing. And also when you have other adversary technologies that you're trying to figure out what it does, and automation of like things of like think of things from the perspective like war of cognitive agents that is uh, sort of like trying to figure out what the other system capabilities doing and also automating the test. Imagine if we adopt AI/ML, can you imagine the complexity of testing that brings on the table, right? Because it is supposed to do a variety of things, right? It's supposed to give you some kind of answer, but how do you know that every time is giving you accurate, right? You can build gain insight into accuracy through some kind of statistical analysis, but at the end of the day, when everything is in a system representation, there's a lot behind it, right? So there's that. I personally feel that's the next big thing is full scale automation testing for AI/ML technologies and a full system of system representation. Is the next big thing.
Yeah. How far away would you say we are from this?
Not too far. You're looking at Chat GPT these days. I personally feel this is a big major milestone that in my lifetime we've seen, mobile devices, laptop, Windows, and all this computers. Chat GPT is the next, is it's totally game changer, and you can sense the power of AI, how your
Yeah.
productivity, yeah, how productivity
And it was
increases.
already all over the place, but in this case, it's democratizing it to for
Yeah,
everybody to use it. I think that's really what the difference is. I mean, Google and others have been using AI for years, but
yeah,
it was a data scientist toy. Right now, it's everybody's toy, and that's a big difference, right? So, in
yes.
fact, my follow-up questions, funny enough, good segue. How do you see, technology like GPT and other AI? disrupt, the industry?
Yeah. So for me, I'd say, you know, for example, Chat GPT and capability, I see that as a productivity tool for many folks, right? Whether you coding or whether you are, you have to write some documents, proposals. You see that as we see that as a productivity. It never gives you 100%, right? It gives you 70% or like 60% or 80% for what you need, but it accelerates everybody, especially the small businesses,
Right.
can take a great use of it. And now these are ChatGPT is a helping hand to much more much faster, right? So
Yeah.
I productivity is the key that I see the benefit of technologies like GPT.
Yeah, and I think it's also maturity in prompt engineering. I can tell you, on Sage, we just released a new
Mhm.
persona. We have a bunch of different persona for lawyers and whatever, right? We
Yeah.
have a prompt engineer persona where you can actually tell your prompt, and he's gonna ask you questions to improve your own prompt. So then you
Mhm.
can copy and paste it and into another persona to, let's say you want to do write an RFP, right? If you have a pretty
Mhm.
basic prompt, it's not gonna do a good job. But if you go to the prompt engineer persona and you improve the prompt, and it asks you questions to
Mhm.
improve the prompt and give you a new prompt updated accordingly, and then you use that in the contracting officer persona, I can tell you the results are incredible. And so, I would argue
Mhm.
for my coding, for example, it's closer to 90% than it is 60%. I think
Mhm.
is really getting to be pretty insane. And I think it's the difference between 60 to 100% is not so much the technology. I think it's more about the human, using the technology. And so prompt engineering is going to become a massive skill that people need to embrace. And people fighting the technology and fighting some of the challenges you see with it, with hallucinations and
Mhm.
people becoming dumber because just like the calculator, you're not going to know basic math anymore. I mean, I get it, right? But the fact
Mhm.
is, we're not going to slow down innovation. It's not going to happen. It's going to happen anyways. So you can't
Mhm.
be the one not using it, right? I think it's the velocity for me, it's at least a 10x velocity enabler. So you can't set it to 10x, you go bankrupt, right?
Yes.
Um,
Yes.
so that's for me that's been pretty mind-boggling, honestly. That's why I created the company, because not a lot
Mhm.
of stuff gets me excited nowadays, and I can tell you that was enough. And the simple fact, that we have 1,200 government teams on Sage in 5 weeks, which is
Mhm.
probably unheard of any product on the planet, tells
Mhm.
you that you know that's clearly something that people resonate with, right? So,
Yes. 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 Yes.
and is it going to disrupt jobs? Probably, but there's two ways of thinking of it. The innovators and the smart people will do 10 times more with the same number of people. The others will cut jobs and do the same amount with less people, but
Yeah.
it's smarter to keep the same people and just do more, but certainly one would argue, it's going to reduce new hires. I was going to hire a marketing person. I'm not going to do that, right? It makes no sense. Sage does all my marketing for me, you know. So that kind of stuff is just interesting to think about.
Yeah. I mean, it also addresses the legacy workforce upskilling kind of challenge that we have, right? Imagine, uh, you know, uh, a regular average Joe sysadmin who doesn't know Kubernetes can go on ChatGPT or Ask Sage and type in, build me a Kubernetes manifest file for Postgres database, and he has everything ready
Mhm.
in his hands. Like that's
100% of my YAML of Sage itself was created by the bot.
yeah,
So you look at the UI, 90% of the UI by the bot, 90% of the backend, 100% of the SQL.
yeah,
It's awesome in regex, regular expressions. I mean, it's just
yeah,
awesome. All the stuff we had to pulse, and for a chatbot, it's always painful, and it's doing an amazing job even explaining regex. I
yeah.
gave my code. I don't like commenting my stuff. I
Mhm,
hate it. So I
yeah,
gave the code. I say, comment this code, and he's just commenting the code for you. I mean, all these tasks that are boring and annoying and slow people down, it's just
mhm,
it's just insane. And even for security stuff, right? You could say, review this code for security, paying attention to
Hmm.
XSS injections, SQL injections. It's all about the prompt, right? And I can tell you, we created this concept of a prompt template where people can share prompts between teams,
Hmm.
and I think that's going to become kind of a database of prompts
Hmm.
to help people, when they are trying to do something, so they can have a starting point instead of creating something from scratch. And I think prompts are going to get more and more complex to get
Yeah.
more and more precise outcomes. And
Yes.
the fact that with GPT-4 now you have 80 pages of text on, you can write an RFP answer completely
Hmm.
automatically. I mean, it's just I have a team. I know one of the Sage customer told me they have 8 people. They used to do 4 bids a month. Now they do 12. Like,
Hmm.
how much money is that worth for them? I mean, they're paying $30 a month per user. I should charge them 10 times more.
Yeah.
It's millions, right? It's millions of opportunities that they now can do with the same number of people. It's mind-boggling.
It's
So,
a great news for small businesses actually.
right.
A an average or mainstream business who had like some product who's not been able to market because they don't have the bandwidth to go market and create material. Now they can, right, without
Yeah.
hiring a lot of people on the team. Right? So
He created the website for me, and I wanted to position the bot on GPT for government, right?
yeah,
And we're number one on Google
yeah.
in 5 weeks. I mean, so it did all the SEO and all the stuff,
Hmm.
to do that. And I just had to ask for it. I don't know. I mean, I know how to do it because I know, but most people don't know. And you know, they could get it turnkey. So it's a company as a business service, right? You look at my
Hmm.
terms and conditions, my license agreement, contracts. Everything came from the bot. The logo of the freaking
Hmm.
bot came from Dali. I mean, it's just, how more do you
Wow.
want? You have no excuse not to be able to do a business nowadays. It's
Hmm.
just it's
Yeah,
just insane.
yeah, it
All
is.
right. So last question before we take a few questions from the public. What keeps you up at night?
Yeah, really, thinking the fact, I actually worried about the war fighters here, and the national security at this point that we face here. That um, our adversaries are getting smarter and smarter. What counter strategies that we have? It really keeps up with us now. It's all about the war fighters and the things that you see in Ukraine could be happening to us, but at some point. But uh, how do we defeat and how do we prepare, and be resilient against non-kinetic and kinetic warfare in the future is really what keeps me up at night.
Yeah. What do you think of the economy?
Um, yeah, with this new definitely this banking turmoil that we're seeing is certainly that's also keeping up with me at night. Certainly worried about that and checking my insurances now that hey, is my money
Everybody check
covered
that
like that?
insurance.
So
Yeah.
yeah.
We had yes, last week we had the Dan, the CEO of ChinGuard, and he was impacted.
Mhm.
He has probably $1 million payroll a month. So 60 people. So
Yeah,
you're gonna be above the limit, and he was using SVB. I mean, he got the money back, but that's just a pretty good awakening. I think for people.
yeah.
So,
Time to
um,
consult with our insurance agents.
yeah, no doubt, no doubt. All right, so let's take a look at some of the questions we got. Yeah. So first, Kenny was just pointing out that she should talk to you because she's interested in digital twin of federal geological input models and if the effort to build is appropriate beyond the U.S. So that's obviously something to reach out offline. But I wanted to
Mhm.
point it out to you and the rest of the people here. I think that's a very interesting use case, a little bit
Yes.
outside of the weapon stuff, which makes it actually pretty intriguing as well.
Mhm.
Mark was saying that we're seeing poor integration of digital engineering, system engineering, and mission engineering. How do we get these tribes, working together more effectively, breaking in the silos, just like we did with DevSecOps. You don't
Mhm.
see a dash or a slash. I hate when people put a slash or a dash between DevSecOps, almost,
Mhm.
creating the silos and the walls again. How do you break those down those walls?
Yeah. So yeah, to break the walls is really you know you have to take this approach. Uh, Model test, model test, model test, model test, and uh, but model test and learn your lessons, and then adapt, build, and kind of do a continuous iteration of our maturity. Is how do you integrate all of these things together on a program, on a large scale acquisition programs too, right? So if you don't early enough, if you have like siloed approaches to do systems engineering and then mission engineering separately, all of this is not going to come together. In agile development, most people say, let's fail fast. I have a different mindset. What I say, let's learn fast. Let's learn fast through digital engineering and adapt. Take the lessons learned and implement for better and improving. And that meets the requirement, and it meets or exceeds the requirement, right? So.
I have my own. I guess I mixed both of you. I call it what is it? Fail fast, learn fast, but don't fail twice for the same reason. So,
Oh yeah,
I guess
yeah.
I combined it all together. I mean, I guess, people need not to be,
Mhm.
fearful of failing. I see that too
Mhm.
much, but it has to be small incremental failure. And I think people freak out when they hear the word fail, but we should
Mhm.
really not freak out anymore. And we need to define it and contain it and really measure it. But we should embrace failing, just like, if you talk to Elon Musk, he's going to tell you if they don't fail enough, they feel like, he feels they're not innovating enough and it's just not good. So I think,
Yeah.
there's a healthy balance there. But at
Yeah.
least, fail fast, learn fast, don't fail twice for the same reason is kind of my motto. So that's the
Yeah.
way I think of it.
Yes. Learn. It's all about learn fast, right?
Right,
Fail,
exactly. And
failure or
the
learning.
learning you're missing. I mean, you're not you're failing like an idiot,
Yeah.
right? So you can't do that. That would be pretty stupid, right?
Yeah.
Failing for the sake of failing is useless.
Yeah.
Um,
You don't start something to just to fail. No, that's not the goal. So.
yeah. So Tim was putting you on the spot because Tim always loves to do that with me, and I love him for that. He
Mhm.
avoids me being a bad guy, so that's good.
Mhm. Mhm.
There are, three big guys, right? In digital engineering, Siemens, PTC, and Dassault.
Mhm.
Which do you think are the most visionary, or if any of them are visionary, and which do you think have capitalized on cloud and ML and data collaboration the most? I think he's trying
Yeah.
to see who he should resell and work with.
Yeah. So I'm afraid actually, from what I've seen from these industry digital twin, they have actually um, the industrial 4.0, what they call it. They create a digital twinning environment just for like from IoT or industry systems and all that. But um, hey, create me a digital twin for military or some federal systems or like enterprise system. They're going to come back and say, well, we don't support that, right? So, or there has been some gaps into that, right? So while I don't know the particular differences between what they offer, but from a high level perspective, these commercial companies are focused on industrial and IoT systems mostly for digital training. Um,
Right.
so, yeah.
Do you see any of them kind of adopting, embracing cloud and modernizing? Because a lot of these solutions are pretty much legacy or old school
Yeah.
desktop apps. Do you see that evolve? Or
Yeah, I think Azure and AWS are really pressing towards that. if you don't hop onto any of those commercial clouds, you're behind, right? They'll be late to the
Mm,
game or they'll be thrown out. So I
right.
don't. Yeah, they have to almost now, right? So
Yeah, there's no choice. Yeah.
yeah.
Um, so I guess Robert was asking. I kind of asked you the question, but you did not do it in 30 seconds. So,
Mhm,
if you have to do an elevator pitch, and most people struggle with elevator pitches, but we'll see if you're good at elevator pitches now.
mhm,
How do you pitch digital twin and the difference between digital twin and MBSC? If you're in
mhm.
a with the PM, you're talking to a program manager, not very technical, and you have 30 seconds to explain. What do you say? TikTok.
Yeah. Yeah, so digital twin, for me, different key difference between digital twin and MBSE are, digital twin can actually become live and support real time. MBSE, while it gives you a blueprint of something that what architecture and what are you trying to structure and what are you trying to build, but that the next phase of that needs to become some kind of simulation or emulation model,
Right.
right? That you can actually do something with that. That's the core difference, right? Take MBSE is first step. MBSE and the representation of the system of systems in the MBSE that goes into a simulation environment is the next step, right?
Right. So live real time. Yeah.
Yeah.
Okay. So I guess this is the last question.
Hmm.
Um, and I'm not sure if it's for you or for me, but you can take a stab at it if you want, or I can just take a stab at it if you don't want. Michael was asking, how do you differentiate prompt engineering versus site reliability engineering? And I'm
Hmm.
happy to do it. It's a DevSecOps question, but it's up to you if you wanna take a
And
stab
now
at it.
go ahead, Nick. You take that. I think you will answer that
Yeah,
better. I
that's
will.
my baby.
Yeah.
So, um, well, I think prompt engineering is about writing. It's about being effectively an English major, right? And typing the right question to GPT, so the bot will be able to give you the best answer that you want with the least number of questions. And so engineering your prompt, engineering your effectively, it's a fancy word to say writing the right questions, right?
Mhm.
In the right tone, and having the right details, and the words matter, right? Concise, precise, whatever outcome you're trying to get to, the tone, if you're trying to speak, as a lawyer, you want to bring that up, with a lawyer with a decade of experience. That's how we do our personas in the system. We effectively tweak the prompt so the body's going to behave in a different way, and you can make it behave the way you want. It could play as a parrot all the way to Elon Musk, all the way to Steve Jobs. I mean, so
Mhm.
so it's all about also like how to phrase things, and when we get to complex use cases. So people that tell me, hey, GPT or whatever is not giving me what I want, I'm like, yeah, blame yourself. You're the problem,
Mhm.
not the bot, right? It's a prompt engineering mistake. So there's a lot of videos about prompt engineering out there, and it's getting there, and people are learning, and English majors are relevant again, I guess. Sorry. But and so SRE is more like the operations of the system and how to run it, and keeping it up,
Mhm.
and minimizing toil, and all that good stuff. So that's the way I think of it, I guess. So first wanted to thank you, because having you is a gift, and I think you were able to really paint a picture of dual engineering, and dual twin, for people that don't always really understand it. We talk a good game, but we all learned a lot, and I think that's
Mhm.
always important to go beyond the buzzwords. So that's what we do here on the show, and you've done a great job. Next Tuesday we're not gonna have an episode, because we were supposed to have the Mirantis CEO, but he was a no-show, so he didn't show up. So I
Mhm.
decided not to have him. That's what you get. And so I canceled his episode. That's what you get. So Mirantis, non-starter. That's where we are. He was supposed to come on the show to explain a little bit about what happened after the buying, of Docker, and explaining, people hear that there's Russian ties with the company. He claims that he's not. So I was giving him a chance to come and explain that to people, but he didn't show up. So I decided to cancel him. So we're not gonna have an episode next Tuesday. We'll see you in 2 weeks with a pretty amazing guest. I'm not gonna tell you who because it's gonna be a surprise, next week. So it's gonna be fun. Uh, with that, I'm gonna give you the last words. So you can share people, to people first how to find you, how to reach out to you if they have more questions, and wanted to thank you again for taking the time and joining us today. So
Yep. Yeah, no, Nick, it was, thank you for having me here. And, this has been my passion of mine. And, we're always posting some educational and some informative things on the LinkedIn, on the Dark Stacks page about digital twin. Always follow us on LinkedIn, and, reach out to us. We are always here to chat. So thank you very much for having me here.
yeah, thank you everybody. You stay safe. In the meantime, you make sure we keep up the good fight so our kids have a fighting chance at winning against China 20 years from now. You stay safe, everybody. Thank you.
Thank you.